Hi everyone. In the last video we were talking about XState state management library. We've been talking about state machines, what state and event means in XState, how the machines are created, and today we are gonna talk about parent state, how can it be implemented and what benefits can we use from it. Just keep in mind that I'm learning too. We are trying to actually use XState library to implement it within our chatbot application. But before we implement it, we'll just try it how XState works, and then if we see that it can be used for our chatbot and it's really beneficial, we'll use it. So let me share my screen and let's see where we finished the last video. So we were talking about states like here, using an pretty simple example where a dog can have two states, either asleep or awake. It cannot have two states simultaneously. And we talked about how the dog switches between those states. And it switches between them using events. So when dog is asleep and it wakes up, it means that he goes from being asleep to awake, right? And he cannot transition from asleep to fall asleep, because to fall asleep he has to be awake first, right? So this is called finite, how it's described. Okay, never mind. Yeah, and that's how it's described in the code. There is a state property, states property, that's specific state, and every state can have a transition using event. And the transitions are deterministic, so transition cannot be can only be made to specific state. And let's see how parent states work. And in the docs it says that a parent state is a state that contains more states, also known as a child states. These child states can only happen when the parent state is happening inside the on-walk state. There could be the child states of walking and running. So clear. A parent state is symbolized by a labeled rectangle box that acts as a container for its child states. Parent states are sometimes known as compound states. A parent state should also specify which child state is the initial state. Okay, so let me open the Stately Studio, and I think it's talking about initial state of the children state is this walking. So this should be defined as initial state, at least one state, right? And I think it's not just at least, but in the on a walk parent state, the initial state is walking, so it's only state which is gonna be initial. It cannot be both, right? Parent and child states are one of the features that make state charts capable of handling more complexity than an everyday state machine. Okay, that's really interesting. Let's see how it looks in the code. Can we check the code here? Okay, structure, sources, code. And show descriptions, generate React app. So interesting. So we want to find on a walk state, right? We have waiting state, on a walk, initial walking, and this state has a sub-property called states. Pretty clear. I mean, it can be nested, and those states can be quite like infinite number of nested states from what it looks like. And yeah, so the walking is initial state of a children's states, and when it speeds up it should be switched to running state, and when it slows down it should be switched back to walking state, right? Description and walk complete. Nice. Okay, that's it. I think it was clear for you. And let's see. There is an atomic state. It's a state that doesn't have any child states. Waiting, walk, complete walking, and running are all atomic states. Right. So yeah, basically no children's states. What are the parallel states? The parallel states is a state where all of its child states, also known as regions, are active simultaneously. The regions are separated inside the parallel state container by a dashed line. Inside the on-walk parallel state, there could be two regions. One region contains the dog activity child states of walking and running, and the other region containing the dog's tail states of wagging and not wagging. The dog can walk and wag its tail or run and wag its tail. It can also do both of these activities without wagging its tail. Okay. So we can see that the parent state on a walk, it has two simultaneous states, and every of those states has an initial state, and the initial state of activity is walking. Initial children's state of tail is not wagging. So both regions should also specify which child state is the initial state. In our tail region, the initial state is not wagging. Yeah, that's what we talked about. And there is self-transition. And that's actually the last part of state machines. Self-transition is when an event happens, but the transition returns to the same state. The transition arrow exits and re-enters the same state. helpful way to describe a self-transition is doing something, not doing somewhere in the process. Not very clear. It's a dog in a dog bagging process. There would be a bagging state with a XState event. And for the dogs who love their food, no matter how many times you go through the XState event, the dog returns to its bagging state. So like closed cycle, right? Okay, and again we can have a state chart and see how it's getting transitioned. And what about this parallel states? We can check the code here. On a walk, that's the state which has two parallel states as the children states. So we go to this part of the code. It has a type parallel, and yeah, it should be specified, right? On arrive home, so it has states, activity, and tail. Yeah, pretty cool. Okay, in the next video we'll talk about what is the actor model, and let's see what can we do with this XState library. Thank you for listening, and see you in the next video. Bye.